Hello students, good afternoon to one and all. Welcome to the session. In this session, we are going to discuss about a C++ program that is nothing but a binary search to search an element using the technique called as binary search. First of all, before going to explain this beautiful program, let me tell you what do you mean by the term called as searching and the types of searching methods. Okay, first of all, what do you mean by searching? The term called as searching, which we have come across in the chapter called as a data structure. Searching means finding the location of an element. Finding the location of an element is called as searching. There are two different methods which we used in the 12th standard. That is, the first one is a linear search, and the second one is a binary search. Linear search is also called as sequential search. Sequential search. How it is going to search the element? That is interesting. Linear, as the name itself indicates, it is going to search the element one after the another. That is why it is called as a sequential, one after the another. Consider an array consisting of 5 elements. Say for example, the elements are 10, 20, 30, 40 and 50. I'll repeat once again. Consider an array consisting of 5 elements. The 5 elements are 10, 20, 30, 40 and 50. In that array, I am interested to search an element called as 50. As we all know that 50 is present in the last location, right? In the first location 10, 20, the second location 20, third location 30, 40 and 50. I am interested to search the element called as 50. In linear search, what we will do, I have to make a comparison right from the first location to the last location. We cannot go to the directly to the 50th last position, that is of A of 4th position. I have to visit first location A of 0, then A of 1, then A of 2, then A of 3, and at the end A of 4. That means 50 is equal to 50. Yes, it is true. Then we'll note down its position. This is what happens in the method called as a linear search. As the name itself indicates, it is going to search the element one after the another. So if the drawback of the linear search is when the given array is too large, say for example, which may be holding the 50 elements from A of 0 to A of 49. 50 elements. The searching element is present in the last position. Say for example, so and so element. That element is present in the last position. But in linear search, it has to make a comparisons right from the first location to the last location. We cannot go to the directly to the A of 49th location. One has to visit A of 0, then A of 1, A of 2, A of 3, and so on. A of 49. It is a time-consuming process. It's a time-consuming process. So this leads to an invention of a second searching algorithm that is called as a binary search. Binary search. As the name itself indicates, we all are familiar with the binary. Binary means what? 2. That means in this searching method, it is going to divide the whole array into 2 subparts. It is going to divide the whole array, which may be consisting of 5 elements or 7 elements or 6 elements or 10 elements. It is going to divide the whole array by knowing the positions of lower element position and higher element position. Lower element position will be 0 and higher element position will be n minus 1. Say for example, if I am giving the elements as a n is equal to 5 means the last element's position will be n minus 1. 5 minus 1 will be 4. Like that, we'll be identifying the positions of first element and the last element. We'll identify the middle element position. How do we identify the middle element's position? The formula is there. Mid, M stands for middle. Mid is equals to begin plus end divided by 2. Mid is equals to begin plus end divided by 2. So we will just identify the middle element's position. Lower element position is known. Higher element position is also known. What we have discovered is middle element's position. After that, we'll just come across some conditions or some possibilities. What we will do, we will take the searching element. We'll take the searching element. Searching element will be compared with the middle element. Searching element will be compared with the middle element. If the searching element is present in the middle element itself means, if the searching element is present in the middle element itself means, we'll note down its position and will comes out and will print the appropriate message. So and so element is present in the so and so position. This is one case. Well, moving to the next one. If the searching element is not present in the middle element, then one of the actions to be taken. If the searching element is not present in the middle element, then what we will do, we'll just encounter a condition if searching element is less than the middle element. I'll repeat once again. If the searching element is less than the middle element, then continue towards to the left half of the array. For you all, for you people all, it will be left this and for like this. I have to stand like this. So, if the searching element is less than the middle element, then continue towards to the left half of the array in this direction. Left half of the array. Suppose if the searching element is greater than the middle element, means we need to traverse towards right half of the array. I'll repeat once again. If the searching element is less than the middle element, then continue towards left half of the array. For me, it's like left half of the array. If the searching element is greater than the middle element, then continue towards right half of the array. These are the sequence of steps to be followed based on the conditions. And the primary thing is, the main basic thing for the binary search algorithm or binary search program, the elements must be in a sorted fashion. The elements must be in a sorted fashion or increasing order. Then only it is possible to search the element. Isn't it? Now, so before going to this, let me draw an array. Let me draw an array consisting of 4 elements. This is 1, 2, and 3, 4. Okay. This will be A of 0, and A of 1, A of 2, and A of 3. Okay. Have a look at this. An empty array. This is A of 0, A of 1, A of 2, and A of 3. And n is equals to, I am going to write here n is equals to as 4. Okay. So I am going to input 4 elements. In that 4 elements only, I am going to search the element. Fine. So this is what the C++ program. Have a look at this. A C++ program to search an element using the technique called as binary search method. Okay, as I said in the earlier, linear search and binary search. Fine. So have a look at this program. There are how many header files? There are 3 beautiful header files where you can see here. The first one, hash include within the angular bracket iostream.h stands for input output stream header file. Second one, hash include iomanip.h stands for input output manipulators. Why we are using that one? For NL or setw. Next one, third one, hash include within the angular bracket conio.h stands for console input output header file. So this header file we are using for 2 functions. One is CLR and another one is get functions. There you can see here 1 and this 2. For these 2 functions I am going to make use of conio.h. Then comes the next one, a declaration of a class. What is the name of class? Have a look at this. Class is a keyword. Class is a keyword. B search is the name of binary search. It's the name of class. Have a look at this name. There is no blank space between B and search. It's a complete one word. Okay. Class is the keyword. B search is a name of class. Okay. Then comes the next line, open flower bracket. What we are doing in this class declaration? A class can hold both data and as well as member function. A class is a user-defined data type which can hold data member and as well as member functions. So no semicolon for this line. The next line, open flower bracket. I am making use of an access specifier called as a private. I am going to mention some of the data members. Have a look at this. Int a of 100, comma, n, comma, element, comma, location. How many data members I am using in this program? 4 data members. The first one is the a of 100. A of 100 is nothing but it's a one-dimensional array. As we all are familiar with the array. What do you mean by array means? Array is a collection of elements having same name and same type. Okay, the name of array is A and the maximum size is to store the elements is from A of 0 to A of 99, which can store 100 elements. N, then ELE stands for element and LOC stands for location. All 4 data members belongs to of type integer type. Those 4 data members were declared under which access specifier? Private access specifier. Then comes the next one more access specifier called as a public. So here we have just mentioned 3 member functions. Have a look at this. The first one, void get data. Void get data member function end with semicolon. The next line, void search member function end with semicolon. And third one, void display member function end with semicolon. So close flower bracket and semicolon. Those 3 lines are called as which we have marked here 1, 2, 3. These 3 lines are called as a declaration of a member function inside the class. Declaration of a member function inside the class. That is what we have. Class begins here and class ends here. There you can see close flower bracket and semicolon. That means end of class declaration. What we have done is we have just declared some of the data members and 3 member functions were declared inside the class and I am going to define outside the class. So in order to define outside the class, one has to make use of a scope resolution operator. It will be asking for a single mark. That is, what is the significance of a scope resolution operator? That is used to define the member function outside the class. I'll repeat once again. It means that scope resolution operator is used to define a member functions outside the class. For that purpose, we'll make use of the scope resolution operator. This close flower bracket and semicolon indicates that end of class declaration. So what we have done is just we have declared a member functions inside the class, and now I am going to define a one by one and outside the class with the help of scope resolution. Have a look at this. As we all know that a C or C++ program execution starts from which particular line? A void main function. Void main function. Every C and C++ program will execution starts from void main function. That's what here. Right. Void main function. Open flower bracket. So what do you call this line? This line I'm making a box here. This line is called as a creation of an object. Creation of an object. Have a look at this. B search. The same name, what we took here, class name, the same name I am using here. B search. There is no blank space between B and search. B search is the name of class. And one blank space here, 1 or 2 blank space doesn't matter at all. And this capital B is nothing but a user-defined object. You need to remember, this is the most important. B search is a name of class, and this capital B is a user-defined object. Why do we create an object? In order to access the member function, there we have declared a three-member function, that is the get data, search, and display. Those are the member functions. You cannot access those member functions directly. One has to use the object name. That is what we are creating an object here. B search is the name of class. B is a user-defined object, and with a semicolon. In the next line, CLR is CR, as we all are familiar with this function. CLR stands for clear and SCR stands for clear screen. Okay, before inputting the value to the program, so everything will be a clear. CLR, SCR is a complete one word. There is no blank space between CLR and SCR. It's a complete one word. The next line, B dot get data. See, you need to concentrate this particular line. What we are doing here is I am trying to access the which member function? Get data member function. B is an user defined object name. B is a user defined object name. Dot is a member access operator. You need to remember the name. This is the most important. See what we are doing. We are trying to access the member function with the help of object name and as well as member access operator. This B is a object name and this dot is a user defined object name. Get data is a member function. There you can see here, get data is a member function. That is what we have declared here in the first line, right? So get data is a member function. Directly get data member function and with semicolon. Do we have any parameters inside this parenthesis? No parameters at all. No arguments at all. Okay. Directly I go to this get data member function here. I'll come to here from this particular line, from this particular line to from this particular line. So I'll just come and hit to this line. Void B search two colons, that is called as a scope resolution operator. Get data is a member function. So that means void. Why we are using the word keyword void? That means this get data member function does not return any value. For that purpose, we are making use of the keyword called as void. I am not at all returning any kind of a value. Neither I am returning integer, nor returning float or character or long or double. So nothing I am returning from this member function. That is why I am using the keyword called as void. Void is the return type specifier. B search is a name of class. Have a look at this. Name of class. That is the same thing. And these two colons are called as a scope resolution operator. Then comes the get data member function. So no parameters at all. It's an empty parenthesis. Open flower bracket. Next line, I am using a cout statement. Cout, how many elements? Cout, string insertion, double quotation start. How many elements? Question mark. A backslash and double quotation close semicolon. This statement is asking me to enter how many elements you would like to insert. I am going to insert a 4. I am going to give the value as 4. This 4 will be stored in which variable? N. See how many elements question mark will print as it is, and this backslash, this is called as a backslash n, double quotation close semicolon. This backslash n indicates an escape sequence. You need to recall the escape sequences in the last year. Backslash n indicates the cursor comes to the next line, or else you can call it as a new line. Backslash n, double quotation close, string insertion, okay? Accepted the value that is 4. 4 is stored in which variable? N. In the next line, cout string insertion, double quotation start, enter the elements. Enter the elements. That means I supposed to input how many elements? I supposed to input 4 different elements. You need to be careful. That is, the elements must be in a sorted fashion. That means in an increasing order. Enter the elements backslash n, double quotation close, string insertion, semicolon. So this for loop and this scene statement, I'll repeat once again. This for loop and this scene statement will execute how many times? 4 times. Because the value of n is 4. Have a look at this. I'm going to write here. So what is the value of I? 0. And what is the value of n? 4. 0 is less than 4, condition true. 0 is less than 4, condition true. I plus plus, this is nothing but a post increment operator. I plus plus is post increment. So 0 is less than 4, yes it is true, the condition is true. When this condition is true means I suppose to execute this cin statement, cin string extraction a of I. A of I means a of 0. The first value that will be stored in the location a of 0. Say for example, I am storing an element called as a 15. 15 is stored in the element, the position that is a of 0. Again it goes to for loop and I gets increased by plus 1. I becomes now 1. Last time it was 0, this time 1. 1 is less than 4, condition true. You need to be very careful. That is, every time I goes on increases by plus 1. Every time I goes on increases by plus 1 and n remains constant. That is 4. So 1 is less than 4, yes it is true. True means cin stream extraction a of I. A of I means a of 1. What is, so the second value, whatever the value which is given by the user, that will be stored in the location a of 1. So I am giving the element as 19. Look at the elements, the first two elements is an increasing order. So you have to be very much careful while giving the elements for the binary search, especially for the binary search. The elements must be in an increasing order. That is the most key point here for the binary search. Okay. Next, again it goes to for loop and I gets increased by plus 1. I becomes now 2. 2 is less than 4. Yes, it is true. The condition is true. Condition true means cin stream extraction a of I. A of I means a of 2. I am going to give the value as 25. 25 will be stored in the location a of 2. Then again it goes to for loop and I gets increment. I becomes now 3. 3 is less than 4. Yes, it is true. The condition is true. Condition true means I am going to execute the cin statement. Cin stream extraction a of I. A of I means a of 3. The fourth value will be stored in the a of third location. So I will be giving the element as 28. Have a look at the elements. 15, 19, 25, 28. All four elements are in which order? Random order or decreasing order? Increasing order. Okay. So again it goes to for loop and I gets increment. Now have a look at this. 4 is less than 4. The condition becomes false. Okay. So when this condition becomes false, it won't execute. This cin statement it won't execute. Have a look at that. How many elements we have given? 4 elements. N equal to 4 elements. Clear. Then comes the next C out, stream insertion. Enter the search element. Enter the search element. Enter the search element. That means we have given 4 elements, that is 15, 19, 25, 28. Among 4 numbers, which number you would like to search? We have given 4 elements. Among 4 numbers, which number you would like to search? I would like to search 28. That means I am going to write here, yes, E stands for searching element. Yes, E stands for searching element. Okay, that is what 28. As we all know that 28 is present in the location, third location. But this program must speak. This program has to tell me the answer. Right? So searching element, ELE, the value 28 will be stored in ELE. This closed flower bracket indicates that end of get data member function. End of get data member function. Again it comes here. After this line, we'll have a b dot search member function. Have a look at this. B is a user defined object. Dot is a member access operator. Search is a member function. There you can see this parenthesis, opening parenthesis and closing parenthesis is called as function. Do we have any arguments inside this parenthesis? No arguments at all, right? So directly it makes a long jump and directly it goes to which one? It comes here. So directly it comes to this line, particular line. Void is nothing but a return type specifier. That means search member function does not return any value. That is why I am using the keyword as void. B search is a name of class. There you can see here. B search, okay. So B search stands for binary search. In shortcut, we have given the name as a B search. Void B search. This is a complete one word. There is no blank space between B and search, right? These two columns are called as scope resolution operator. And search is a member function. There you can see here empty parenthesis. Empty parenthesis indicates does not return no arguments at all or no parameters at all. Fine. The next line. This is the most important. The statements in this entire program. Have a look at this. There we are declaring some local variables. I am declaring some of the local variables for only for which member function? For search member function. So begin in shortcut we have given as BEG. Okay, BEG stands for begin, END stands for end, and MID stands for mid. I'll tell you once again. Begin, end, middle. Begin, end, middle. These three variables are of type an integer data type. There you can see the data type as integer. In the next line, what we are doing, I am just assigning a value for the variables. Here, LOC stands for location. LOC stands for location. There you can see location is already declared here in the declaration part in the beginning of the program. But in the middle of the program, what we are doing, I am just assigning a value. Location is equals to -1. Why we are assigning location is equal to -1 in the program? Because array initialization starts with the 0th element, henceforth we are taking location as a -1. I'll repeat once again. Location is equal to -1. That means array initialization starts with 0th element, henceforth we are taking as -1. Got it? In the next line, begin is a variable that is declared in the just above. Now I am just initializing as 0. The next line, end is equals to n-1. Okay, what is the value of n? There you can see here, n is equal to 4. 4 minus 1 is 3. 3 will be assigned to n. Okay, next comes the condition, that is the straight away a while loop. This is about the declaration, and these three are nothing but a initialization, assignment statement. -1 is assigned to location, 0 is assigned to begin, n-1 is assigned to end. Straight away next comes the condition, that is a while loop. As we all are familiar with the while loop is also known as entry controlled loop or else pre-tested loop. That means it is going to check the condition at the beginning. It is going to check the condition at the beginning. If it is true, it allows us to execute set of statement. If it is false, it comes out of the while loop and executes next statement in the program. The same thing we have studied in the last year, along with the syntax, flowchart, and explanation part, along with some examples. Right. While begin is less than or equals to end. What is the value of begin? What is the value of begin? Begin is 0. Okay. What is the value of end? N is equal to n-1. What is the value of n? 4. 4 minus 1 is 3. Let me write some values here. I'll just make a space here. So begin is 0. I am going to write here in a small letter. Begin equal to 0 and end is equals to n-1. N is 4. 4 minus 1 is 3. So we know the two values 0 and 3. 0 is for begin, 3 is for end. We'll substitute those two values in this condition, in this while loop. Begin is less than or equal to end. I am going to substitute these two values in the expression. Have a look at this. 0 is less than or equal to 3. 0 is less than 3. Yes, it is true. 0 is less than 3. Yes, it is true. Of course, it is true, I say. So, condition 2. 0 is less than 3 means condition will be true. What I said in just a couple of minutes back, when the while loop is true means it allows us to execute some set of statement or compound statements. If the condition is, if the while loop is false means it comes out of the while loop and executes next statement in the program. But our condition is true. 0 is less than 3. Yes, it is true. True means I am going to execute the statement, this one. Have a look at this. Mid. equal to mid is already declared here, right? Mid is equals to begin plus end divided by 2. Mid is equal to begin plus end divided by 2. What is the value of begin? 0. What is the value of end? 3. 0 plus 3. 0 plus 3 will be 3 only. 0 plus 3 will be 3 only. 3 divided by 2. See, 3 divided by 5. See, 3 divided by 2 will get the answer as 1.5. I am considering only integer part, that is 1. Okay, then 1 is assigned to, mid. 1 is assigned to mid. So you need to have a look at the values. So begin position is 0, end position is 3, middle element position is 1. So I am going to mark in this array. This is what I call it as a begin, and this is what I call it as an end, and for this I will call it as a mid. So in the next line, so what we have done is we have just find the position of the middle element. Right? Middle element position is 1. Okay. Next straight away condition, if open parenthesis element is equals to, look at this. This 2 equals to must be read it as a is equal to. This must be read it as a is equal to. That is nothing but a comparison operator. Then if element is equals to a of mid. Element means what? That is what? Searching element. What is the searching element? 28. I am going to substitute here 28. 28 is equals to a of mid. A of mid means a of 1. What is the value stored in the a of 1? 19. That means 28 is equals to 19. 28 is equals to 19. Condition false. 28 is not equal to 19. The condition is false. These two statements will execute only when the condition is true. But our condition is false, right? 28 is not equal to 19. The condition is false. Condition false means I am going to execute after the else part. Okay, I won't execute these two statements. I will execute after the else part. I'll come here. Okay, these two statements will be executed only when the condition is true. But my condition is false, right? 28 is equal to 19. Condition false. Condition false means I am going to execute after the else part. After the else part means this is what the statement. If element is less than a of mid, element with what? Searching element. Element means searching element, that is 28. There you can see here 28. A of mid means a of 1. What is the value stored in the a of 1? 90. I am going to write here 28 is less than a of mid means a of 1. What is the value stored in the a of 1? 90. 28 is less than 19. 28 is less than 19. Condition false. 28 is less than 19. Condition false. Condition false means I am going to execute after the else part. That is what after the else part. So else part normally we have a condition. Begin is equals to mid plus 1. Begin is equals to mid plus 1. Mid is 1. 1 plus 1 is 2. 2 is assigned to begin. So what was the previous value of begin? It was 0. Now this time begin is now 2. Okay. After implementing this mid plus 1, mid is 1, 1 plus 1 is 2. Okay. Again it comes here and again it executes while the array will be revised. Okay. Let me draw an array. So no, once again I'll just modify this one. So what I will do is I'll just strike out this one. So the left elements are only two elements, this and these, 25 and 28. Okay. So it comes here in the while loop. While begin is less than or equal to end, begin is 2, end is 3. 2 is less than 3. Yes, it is true. 2 is less than 3. Yes, it is true. The condition is true. When this condition is true means I am going to execute the set of statements here, open flower bracket. Mid is equals to begin plus end divided by 2. Begin is 2, end is 3. 2 plus 3 is 5. 5 divided by 2. Again, see, mid is equals to begin plus end divided by 2. Begin is 2, end is 3. 2 plus 3 divided by 2. That means 5 by 2 will get the answer as 2.5. I am considering only integer part, that is 2. 2 is assigned to mid. Okay, 2 is assigned to mid. Right. 2 is assigned to mid. Then comes the condition again. If element is equals to a of mid, element means searching element. That is searching element is 28. 28 is equals to a of mid. A of mid means this. See, this element is the begin and this element is end and this element itself is the middle. That is what I am just marking. This is begin and this is end and this itself is the mid. Now, so what I will do, if element is equals to a comparison operator, if element is equal to a of mid means a of 2. What is the value stored in the a of 2? 25. 28 is equal to 25. Again condition false. 28 is equal to 25. Condition false. Condition false means I am going to execute after the else part. So I come here. If element is less than a of mid, element means searching element. Searching element is 28. 28 is less than a of mid. A of mid means a of 2. What is the value stored in a of 2? 25. 28 is less than 25. 28 is less than 25. Condition false. Condition false means I am going to execute after the else part. That is begin is equals to mid plus 1. Mid is already 2. 2 plus 1. 3. 3 is assigned to begin. So I'll just update the value. The previous value of begin was 2. Now this time begin is 3. After that again it comes to while loop. So while begin is less than or equal to end. Okay. So I'll just update the array. Now only one element is left here. This is a of 0 and this is a of 1 and this is a of 2 and at the end a of 3. So this element itself is a begin, middle and end. The remaining only one element, that element itself becomes a begin, middle and end. Then comes the condition. While begin is less than or equal to end, begin is 3, end is 3. That means begin is 1 minute. I'll just update this middle. Oh, middle that let it be 2. Okay. While begin is less than or equal to end, begin is 3, end is 3. 3 is less than or equal to 3. Because of equal to sign, the condition is true. Because of equal to sign, the condition is true. Condition true means we'll encounter this expression. Mid is equals to begin plus end divided by 2. Begin is 3, end is 3. 3 plus 3 is 6. 6 divided by 2 will get the answer as 3. That 3 is assigned to mid. Have a look at this. Begin 3, end 3, mid 3. Now comes the condition. If element is equals to a of mid, element is nothing but a searching element. Searching element is 28. 28 is equals to a of mid. A of mid means a of 3. Okay. So a of, what is the value stored in the a of 3? 28. 28 is equal to 28. 28 is equal to 28. Condition true. Condition true means I am going to execute these two set of statements because the condition is true. Location is equals to what? Mid. So what is the value assigned to mid? 3. 3 is equals to which variable? 3 will be assigned to location. At the end, break. That means we are halting the execution and comes out of the program. Okay, then directly it comes here. Okay. So b dot display. B is an user defined object. Dot is a member access operator. Display is a member function. Where is member function? Display member function. It's here. So void b search. Void is the return type specifier. B search is a class name, and these two colons are called as a scope resolution operator. Display is a member function. Open flower bracket. If Look, open parenthesis, location is greater than or equal to 0. What is the value of location assigned to? See, location is equal to mid. What was the value of mid? 3. 3 is assigned to location. What value we were initialized to location? -1. Okay. 3 is replaced by this initially it was stored as -1. Now the new updated value will be 3. 3 will be assigned to location. So we'll just substitute in the expression the condition if location is greater than or equal to 0. What is the value of location? 3. 3 is greater than or equal to 0. Yes, it is true. Condition true means I am going to execute the first statement, that is before the else, because my condition is true. See out string insertion double quotation start position is equals to will print as it is. Okay, because that is written under double quotation. String insertion, what is this? LOC. What is the value stored in location? 3. That 3 is going to print. That means 28 is the element that is present in the position, third position. Have a look at this. This is 0th position, first, second, third. Search is successful, found at location, third place. This is one case. We'll go to the another case, okay? This again, I would like to take the same elements, that is 15, 19, 25, 28. Now, instead of going with the searching element as 28, I'll go with the searching element as 20. I'll go with the searching element as 20. This is A of 0, and this is A of 1, this is A of 2, and this is A of 3. So after that, after printing an appropriate message, search is successful, position, location we will print. Then we'll execute get. At the end, close flower bracket. So now, again with I'll go with the same n is equal to 4 elements. Instead of going with the different elements, now this time, searching element is 20. Then you can see 20 is there in the list, 20 is not there in the list. So what I'm going to get the message, search is unsuccessful. Search is unsuccessful. Okay. So assume that we have accepted n value, and directly I'll go with which member function? Search member function. Okay. Instead of going to the get data and all, directly I'll go with the search and I'll go with the display. So why is the return type specifier? B search is the name of class. These two columns are called as scope resolution operator. Search is a member function. Open flower bracket. Int begin comma end comma mid. Okay. Data members were declared local variable. Location is initialized as -1. Begin is equal to 0. End is equal to n minus 1. N is 4. 4 minus 1 is 3. So I'll just update these three values. Okay. Begin is equal to 0, end is equals to n minus 1. N minus 1 means 4 minus 1 is 3. Directly I'll write 3. Okay. Mid we need to calculate. Begin equal to 0, end equal to n minus 1. 4 minus 1 is 3. That is what? Straight away condition while begin is less than or equal to n. Begin is 0. 0 is less than 3. Yes, it is true. True means I am going to execute this one. Mid is equal to begin plus end divided by 2. Begin is 0, end is 3. 0 plus 3 is 3. 3 divided by 2 is 1.5. 1.5 I am going to consider only integer part, that is 1. I am discarding the fractional part. So 1 is assigned to mid. Next, so what we will do, I will just highlight the position. This is what the begin, and this is what the end, and this is what the mid. Okay. The next one, condition if element is equals to A of mid. Element is nothing but a searching element. Searching element is equals to A of mid. A of mid means A of 1. A of mid, so A of mid means A of 1. What is the value stored in A of 1? 19. Searching element is 20. 20 is equal to 19. 20 is equals to 19. Condition false. Condition false means I am going to execute after the else part. So it comes here. So we'll execute after the else. Next, if element is less than A of mid, Element means searching element. Searching element is 20. I am going to write here 20 is less than A of mid. A of mid means A of 1. What is the value stored in A of 1? 19. 20 is less than 19. 20 is less than 19. Condition false. Condition false means I am going to execute after the else block. That is begin is equal to mid plus 1. Mid is 1. 1 plus 1 is 2. 2 is assigned to. 2 is assigned to begin. Okay. Again it comes here and in the while loop. So while begin is less than or equal to end. So what I will do, I'll just update the array. So 1, 2, 3, these two elements will be discarded. Okay, only two elements will be left. So while begin is less than or equal to end, begin is 2, end is 3. That means 2 is less than 3. 2 is less than 3. Yes, it is true, condition true. Mid is equals to begin plus end divided by 2. Begin is 2, end is 3. 2 plus 3 is 5. 5 divided by 2 will get the answer as 2.5. I am considering only integer part, that is 2. If element is equals to, so I just 1 minute. This is begin, this itself is the middle, and this is end. Okay. Next, if element is equal to A of mid, elements means searching element. What is the searching element here? 20. 20 is equals to A of mid. A of mid means what? A of mid means A of 2. What is the value stored in A of 2? 24. That means 20 is equals to 24. Condition false. Condition false means I am going to execute after the else block. After the else block means here. If element is less than A of mid, element is 20. A of mid means A of 2. What is the value stored in A of 2? 24. So I am going to substitute the value as 24. 20 is less than 24. 20 is less than 24. Yes, it is true. 20 is less than 24. Yes, it is true. True means I am going to execute this statement before the else. Before the else. Before the else. End is equal to mid minus 1. Mid is 2. 2 minus 1 is 2 minus 1 is 1. 1 is assigned to. 1 is assigned to end. 1 is assigned to end. Okay. That comes here. Again it comes here while loop. Have a look at the condition. Begin is less than or equal to end. What is the value of begin? 2. 2 is less than 1. 2 is less than 1. 2 is the value of begin. Less than. What is the value of end? 1. 2 is less than 1. Condition false. 2 is less than 1. Condition false. Condition false means it comes out of the while loop. It comes out of the while loop. Okay. And then comes this member function will directly execute. Okay. B dot display means directly comes this member function void. B search is the name of class. These two colons are called as scope resolution operator. Display is the member function. In the next line, if location is greater than or equal to 0, you need to observe the value of location. The location value gets changed only when the element is found. If the element is not present in the array means the location remains same. So location value did not updated. Okay, location remains -1. The same -1 I am going to substitute in the condition. If location is greater than or equal to 0, what is the value of location? -1. -1 is greater than 0. -1 is greater than 0. Condition false. Condition false means I am going to execute after the else part. That is your string insertion within the double quotation. Search is unsuccessful. Search is unsuccessful. That means what you are searching for 20, but 20 is not present in the list. That is why it is going to display an appropriate message called as search is unsuccessful. Okay, this is how it is going to execute. The basic things for the binary search is what exactly it will do means it will divide the whole array. It will divide the whole array into two halves. By knowing the positions of lower element position and higher element position, we'll able to calculate the middle element. Mid is equals to begin plus end divided by 2. We'll identify the middle element's position. What we will do, we'll compare the searching element with the middle element. If the searching element is present in the middle element, we'll note down its position and will come out of the algorithm and will print an appropriate message. So and so element is present in a so and so location. Suppose if the searching element is not present in the middle element itself, we will encounter this condition. If element is less than A of mid, if element is less than A of mid, Then if the searching element is less than the middle element, means we have to traverse towards left half of the array. For you people, it will be the left half here and right half here. Okay. If the searching element is less than the middle element, means it has to traverse towards left half of the array. If the searching element is greater than the middle element, means we need to traverse towards right half of the array. If the searching element is greater than the middle element, means we need to traverse towards right half of the array. If the searching element is not present, means we'll come across the condition. We'll come across the condition as end is greater than beginning. At that time, I am going to display an appropriate message called as search is unsuccessful. This is how the binary search algorithm works. The most important thing in the binary search is elements must be in a sorted fashion. That is the key. That is the key of binary search. Elements must be in a sorted fashion. Then only it is possible to search the element. Okay. So we have just find the definition of searching, the two different methods, and this binary search program. Searching means finding the location of an element. There are two different types of searching techniques. The first one is a linear search, and second one is a binary search. Okay, in linear search, it is going to search one after the another, or else you can call it as a sequential, one after the another, one after the another. It's a time-consuming process. If the searching element is present in the last position, then it has to make a comparison right from the a of 0 to a of n minus 1. But in the binary search, it is going to divide the whole array into two sub-arrays. By knowing the positions of lower element position and higher element position, we are able to calculate the middle element's position. Then we'll compare the searching element with the middle element. If it is present, means we'll note down its position, will come out. If searching element is less than the middle element, means towards left half of the array. If the searching element is greater than the middle element, means we need to traverse towards right half of the array. But elements must be in an increasing order, especially for a binary search program. Okay, so this is about the binary search. Thank you for watching this video.